Dear students, as you are the part of complementary chemistry course, we have to study atomic structure and chemical bonding as the second chapter in your first semester theory chemistry. Now we are starting with that chapter. The name of the chapter is very clear. It has two different aspects to discuss in it. They are atomic structure at first, and later we have to see how chemical bonds can be formed. Initially, we are now starting with atomic structure. Few important terms related to atomic structure are atoms, fundamental particles in an atom, and who discovered them, and finally their properties. Atoms are the smallest individual unit of matter from which elements are formed, and these atoms were considered to be indivisible in the early times of science, and the name atom was derived on that basis. But fortunately, later on, the scientists succeeded in dividing the atoms into some other fundamental particles and subatomic particles. In your plus 1 classes, you have studied about the fundamental particles of an atom. They are mainly 3 in number, which are electrons, protons, and neutrons. And you have studied the story behind the discovery of each and every fundamental particle. At first, we have discovered electron, and the credit of this discovery belongs to J.J. Thomson. And later in 1920, proton was discovered by Rutherford, who actually discovered nucleus of the atom. And in 1932, I think neutron was discovered by James Chadwick. Few important properties of these 3 fundamental particles can be summarized as this is fundamental particle, this is discovery, who discovered it and who hold the credit of discovering that fundamental particle, and then charge, and finally mass. These are the basics which we have to discuss in this current table. First, electron. Electron was discovered by J.J. Thomson. Proton discovered by Rutherford, and neutron by James Chadwick. Charge of electron is -1. Proton is +1. and neutron is chargeless. But actually charge is 1.6 into 10 raised to minus 19 coulomb. So electron possesses a charge of minus 1.6 into 10 raised to minus 19 coulomb, while proton possesses a charge of plus 1.6 into 10 raised to minus 19 coulomb. So it is the fundamental value of unit charge. And we are telling that electron possesses unit negative charge and proton possesses unit positive charge, while neutron is chargeless. And now let us see the mass of these particles. First, electron has the lowest mass among the three, which is 9.1 into 10 raised to minus 31 kilogram. Proton is 1.67262 into 10 raised to minus 27, again kilogram. Here it is 1.67727 into 10 raised to minus 27 kilogram. From these three masses, it is very clear that both protons and neutrons occupy approximately same mass, and their mass is around 2000 times or 1837 times exactly greater than the mass of electron. Electrons have comparatively less mass. With this, we come to the end of discussion on properties. Now we have atom models. In +1 classes, you have studied about Thomson's model, Rutherford model, and something new you have to add here, and Bohr's model and quantum mechanical wave model. According to Thomson, an atom is spherical in shape and positive charge is distributed throughout the body of the atom, while negative charge is embedded in this body here and there, so as to get stability to atom. That means total positive charge is neutralized by total negative charge, and hence atom is always neutral. By this neutrality, atoms are found to be stable. The fundamental mistake done by Thomson is that his postulates of the presence of positive charge throughout the atom. This model accepted for many years until Rutherford entered into the picture with his solar or planetary model. The major postulates of Rutherford is that entire positive charge and most of the mass in an atom is contained in a small region called nucleus. Entire positive charge means protons, and most of the mass means the particles having higher mass. Both neutrons and protons are present in a small region called nucleus. That was his first postulate. Second one was the electrons are revolving around the nucleus through electrons are revolving around the nucleus through circular path. Circular path. You have to understand the second postulate very clearly, because this statement or this postulate is further developed by Bohr in his time. Second one is negatively charged electrons are revolving around the nucleus through circular paths, and these circular paths are called orbit, not orbital, orbit. The attraction between positively charged nucleus and negatively charged electron is purely electrostatic, which was his third assumption. By these three assumptions, he came to the end of his model. Entire positive charge and most of the mass are concentrated in a small region called nucleus. Negatively charged electrons are revolving around this nucleus through circular paths, which we can call as orbits, and the interaction between this positively charged nucleus and negatively charged electron is perfectly electrostatic. At the time of Rutherford, this model was good, in agreement with the theories existed on that stage. But later, Maxwell proposed electromagnetic wave theory. Based on this theory, when a charged body is accelerated, it has to emit radiation in the form of energy. If this concept is applied in Rutherford, what actually happens is that electron is a charged body, with charge negatively charged body. When going through a circular path, automatically this electron has to experience acceleration. So, when electron is revolving through a circular path, electron has to experience an auto acceleration. When this charged body is accelerated, electron definitely lose the energy. When electron loses its energy, radius of the circular path decreases. That means initially electron is moving like this, but when energy decreases, it moves close towards the nucleus and slowly coming to the nucleus and finally fall into nucleus, and atom will collapse. So, by electromagnetic wave theory of Maxwell, Rutherford failed to explain the stability of atom, energy of the electron, and arrangement of electron. These were the three mistakes, three drawbacks of Rutherford. Later, Planck introduced its quantum theory of Max Planck. Based on quantum theory, energy can absorb or emit discontinuously in the form of small packets of energy called quanta, and in the case of light energy, we can call it as photon. Second postulate is that energy of the photon or energy of the quanta is directly proportional to frequency of radiation. Therefore, E equal to h nu, where h is called Planck's constant, and we also have E equal to nh nu. These were the postulates in quantum theory introduced by Max Planck. Energy is proportional to frequency. Energy can absorb or emit discontinuously in the form of small packets, and energy is equal to nh nu. Based on that theory, Bohr developed his model, Bohr model. Actually, This chapter starts from Bohr model. But before coming to the Bohr model, I simply explain the stories which finally leads to the development of Bohr model. So, you are welcome to Bohr model. What are the postulates of Bohr model? What are the postulates of Bohr model? See it one by one. Electrons are revolving around the nucleus through circular path. Up to this postulate is from Rutherford. But after it has been introduced by Rutherford, based on the electromagnetic wave theory, electron will move from a circular path to spiral path and finally reach the nucleus, which leads to the collapse of atom. So, to rectify that problem, sentence has been modified like this. Electrons are revolving around the nucleus through circular path of definite radius and energy. That means, as long as an electron is moving through a circular path, there will be no change in the radius of that path and there will be no change in the energy of that path. So, that electron does not go to the spiral path. It will always have an orbit. It will move through an orbit of definite radius and definite energy. So, there is no change in energy and we are calling it as stationary state. This circular path is called orbit, which can be designated as first orbit, second orbit, third orbit, like that, or we can call it as K, L, M, N, etc. These are all you have studied in the earlier classes. Orbits can be designated like this. Second one, as long as the electrons move through a particular orbit, they can't absorb or emit energy, or their energy in a particular orbit is fixed. Since the energy of orbit is fixed, we are calling this orbit as stationary state. This may be asked in exams also. Why orbits are called stationary state? It is very simple answer, because of the constant energy of orbits. We are calling them as stationary state. Third one, when electron excite from lower to higher energy level, they have to absorb energy. When they move from lower to higher level. At the same time, when they move from or de-excite from higher to lower level, this is the higher level, move to lower level, then liberation or emission of energy is possible. When electron is moving through a particular orbit, there is no chance of emission or absorption. But when electron is ready to go to higher levels, they have to accept or absorb energy. When electron is moving from higher level to lower level, they have to emit the energy. So, absorbed energy or emitted energy. During this transition of electrons from higher to lower or lower to higher orbit, energy change is possible. That energy change can be expressed as delta E. Delta E stands for change in energy equal to E2 minus E1. What is E2? Energy of higher level minus E1, energy of lower level. From the Planck's quantum theory, E equal to h nu. So, E2 can be written as h nu 2 minus E1. We can write it as h nu 1. We have commonly h here. So, h into nu 2 minus nu 1. Nu 2 minus nu 1 means change in frequency of the radiation. Change in frequency. So, h into delta nu. So delta nu equal to, we have to take this h here, delta E by h. This is one fundamental equation. This is the fundamental equation. The energy change associated with electronic transition is given by delta E by h. And the next postulate is only those orbits are permitted in which angular momentum of an electron is an integral multiple of h nu by 2 pi. This is the condition of licensing of electrons. What I mean is that we have nucleus at the center and so many orbits around it. This is nucleus and so many orbits, K, L, M and so on. If the angular momentum of electron is h by 2 pi, angular momentum of an electron is h by 2 pi, then if the angular momentum of electron is, this is the expression for angular momentum, is h by 2 pi, that means n equal to 1, which implies that electron should move through the first orbit. If an electron is moving through second orbit, it should have angular momentum of 2h by 2 pi, that means h by pi. If an electron is ready to move through third orbit or mth shell, there will be an angular momentum of 3h by 2 pi. So simply we can say that from the angular momentum of an electron, it is possible to identify the orbit through which it actually revolves around the nucleus. If this value is 3h by 2 pi, it is moving through the third orbit. If MVR is h by pi, it moves through the second orbit. If it is h by pi, it moves through the first orbit. This is a licensing. Only those orbits are licensed for the electrons where their angular momentum is an integral multiple of this value. These are the major postulates proposed by Rutherford in his atomic theory. Even if he succeeded in overcoming the difficulties or drawbacks of Rutherford, we can see lot of demerits also. The merits and demerits of Bohr model can be discussed in a separate class. Thank you.